In this video, we are going to learn about energy. So energy, the unit for energy is joule, and the definition is the capacity to do work. So in this syllabus, we are going to learn about three main types of energy. So the first one is gravitational, potential energy. So that is our first energy. The second one, we are going to learn about kinetic energy. Okay, and the third one, we are going to learn about elastic potential energy. Okay, so we're going to go through each of the energy one by one. So we're going to start with gravitational potential energy. So gravitational potential energy is energy stored in an object due to its position. Okay, so let's say this is the floor. Okay, and then we have an object here. So the position of this object causes it to have a potential energy, specifically gravitational potential energy. Okay, so the formula for gravitational potential energy is E equals to mgh, where E is the gravitational potential energy, m is the mass, g is the gravitational acceleration, h is the height. Okay, let's go back to this object. So let's say this is actually 2 kg and the distance from the floor is 5 meter. So to calculate the energy here due to its position, which is the gravitational potential energy, we can use the formula E equals to mgh. So m is the mass, which is 2 kg. Okay, g is the gravitational acceleration, which is 10, and h is the height or the position relative to the floor. So it is 5 meter. So we get 100 joule. You can only use joule if the mass is in kg, the g is meter per second squared, and also the height is in meter. Okay, let's do another example. So if there is an object here, okay, let's say this distance here is 2 meter. Okay, and then the question says that the energy in this object due to its position is 200 joule. Okay, the question is calculate the mass. So we know that the energy due to its position is the gravitational potential energy, and we already know that the formula is E equals to mgh. So the energy is 200 and we're trying to find its mass. Its gravitational acceleration is 10 because that is constant on Earth, and also the height is 2 meter. So m times 10 times 2 is 20 m, and that is 200. So using simple maths, we can calculate 200 divided by 20 is 10. So that is our mass. So the unit for mass here is kg, because the unit given for the energy is joule. Remember, if you have the energy unit as joule, then the mass has to be in kg, the gravitational acceleration has to be in meter per second squared, and also the height has to be in meter. So that is for gravitational potential energy.